MEM School of Engineering, Department of Electrical and Electronics Engineering, online classes, subject Digital Logic Circuit, unit number 5, biggest here. So last class we discussed about a basic behavioral modulation, behavioral model and structural model like that we discussed with the examples of some half adder and full adder design. So now we are going to explain about now I am going to explain about the design description of compilation. That is BHDL compilers are sometimes called analyzers. The term analyze means to check a design file for syntax and static semantic errors before it is simulated. So this term is sometimes used instead of the term compile, because compiling typically means to generate executable object code. In contrast, code generation for BGSDL was initially associated only with the simulation. So syntax error are violations of the language grammar. Semantic error are violations of the meaning of the language. So static semantic errors are in the meaning that can be detected by a compiler before a simulation is performed. So dynamic semantic error can only be detected during simulation. So verification. So verification is the process used to demonstrate the correctness of a design. We verify that our design description meets its functional and timing specification. So before the target PLD is programmed. So generally speaking, verification using simulation can show the existence of errors in a design, but cannot provide that that the design is correct. The process of verification often consumes a significant percentage of the total design effort. So this is the typical constituent of a simple test bench, that is stimulus generator, UUT, and a response monitor. Unit means unit under test. So stimulus generator for combinational designs, only combinations of the values of zeros and ones, sequence of combinations are applied. Response monitor. In response to each stimulus, the UUT output values must be checked to verify that they are identical to the exploited. So this is explained by project Waveforms, stimulus generator, half adder with the response monitor. In order to simulate the operation of a UUT using a test bench, we must actually simulate a test bench, since the UUT is simply a component in the test bench. Library, IEEE library we are using here. Architecture waveform of text bench is stimulus signals, signal A, B, and standard logic, that is the input, that is signal a sum and carry, that is the output, standard logic begin. UET port map. Entity half adder port map. A greater than A underscore TB, B greater than PDB, sum is equal to sum and carry, carry out B. So we are defining the value for the AB and sum and carry. Then A is equal to 0, 1 after 40 seconds, B is equal to 0, 1 after 20 seconds, 0 after 40 seconds, 1 after 60 seconds in waveform. So this is the format of output. So the signals displayed are those used to connect the UET to the text bench. Because this is a functional simulation, the waveforms do not show any delay from an input change to a corresponding output change. So that is, as soon as a UET input changes, its output responds instantaneously. Next one is synthesizer. The objective of a synthesizer is to synthesize logical that behaves identically to simulated behavior of the design description. In effect, a synthesizer translates a design description into a functionally equivalent gate level logic implementation. A synthesizer generates the required Boolean equations. It automatically carries out logic and state minimization and stores the simplified Boolean equations in an intermediate form. The output of the synthesizer is a gate level logic description. A gate level logic implementation is sometimes referred to as a registered transfer level. Register transfer level, that is RTL implementation. This level describes the logical in terms of registers and the Boolean equations are for the combination logic between the registers. Of course, for a combinational system, there are no register and the RTL logics consist only of combinational circuits. So this is the register transistor logic definition. So the main objective of the synthesizer is to synthesize the logical that behaves identically to the simulated behavior of the design description. In effect, a synthesizer translates a design description into a functionally equivalent gate level logic implementation. A synthesizer generates the required Boolean equation. It automatically carries out logic and state minimization and stores the simplified Boolean equations in an intermediate form. The output of the synthesizer is a gate level logic description. A gate level logic implementation is sometimes referred to as a register level implementation, that is RTL. So this level describes the logical in terms of registers and the Boolean equation for the combinational logic between the register. Of course, for a combinational system, there are no register and RTL consists only the combinational logic. This is the half adder synthesis logic. The synthesizer produces the two output files, a big SGL netlist and a technology dependent gate level netlist. The netlist is a textual representation of the interconnection of logical elements. Place and route tool is software used to automatically map or fit synthesized logic to a target PLD architecture. The place operation selects and configures specific logic primitives in the PLD architecture for each logic primitive in the technology dependent netlist. The root operation determines the path for each connection between two logical primitives.